For the last part of the question, to find out when we are at minus 25 meters per second, we're going to use a formula. We're going to use is change in position is v initial times time plus a half acceleration times square. It's one of the formulas for constant acceleration which we have here. The only acceleration we have is gravity. So if I put that in, I want to go to minus 25 meters from 0 meters. Therefore, minus 25 meters or equal to my v initial 20 meters per second times the unknown time plus a half of minus 10 meters per second square times time square. This gives me minus 25 meters equals 20 meters per second delta t plus actually minus 5 meters per second square delta t square. Now we have t square here, so we need to use that formula for quadratic equations to solve it. That formula says that if you have a quadratic equation of the form ax squared plus bx plus c equals 0, the answer will be b plus minus square root b squared minus 4ac. There are two solutions to that. We're going to see one later on. Divided by 2a. So to bring it into that form over here, first of all I'm going to simplify it a little bit. I'm going to divide by 5. Minus 5 meters equals 4 meters per second times time minus 1 meters per second square times square. I can actually divide by meters all over, so I get rid of that. Now here I'm going to multiply with the time, so my s is actually going to go away. Here I'm going to multiply with the time square, so my s squared is going to go away. Now I take it all on the other side, which will give me 1 delta t squared minus 4 delta t minus 5 equals 0. Therefore this is my A, this is my B, this is my C, and my solution time 1, 2 becomes B minus, oh, here was an error. The formula actually reads minus B. So 4 seconds plus minus square root of 16 minus 4 times 5 plus 20 over 2 times a over 2. Now this one here is 36, so the square root is 4 plus minus 6 divided by 2. Now we have two solutions. T1 is 4 plus 6 is 10 divided by 2, 5 seconds. and t2 is 4 minus 6 minus 2 minus 1 second. Now how come we have two solutions? Well, on the way down, after 5 seconds, we passed that mark. And theoretically, if our object would have been thrown from further down, we would have passed that mark as well. Basically 1 second before it came to where we were standing. But for our problem here, this one is not a real solution, because we were actually throwing the stone from our cliff. So the solution here is at 5 seconds. You can even look at the graph and see if that makes kind of sense. We go 20 meters up, 20 meters down again, and then we should be another 20 meters down. If you look at it, here the average velocity is minus 25 meters per second, and we're going for 1 second, so this area is 1 second times minus 25 meters per second gives us 25 meters. So the graph tells us that our calculations were correct, and we are at minus 25 meters after 5 seconds.